Welcome back to OMG Science. In our prior videos, we've talked about the different types of chemical reactions. We've compared chemical reactions to the dating scene. We've talked about how synthesis reactions are like two people finding each other and starting to date. And we've talked about how decomposition reactions are like a couple breaking up and going their own ways. Finally, we discussed the horrible feeling of your significant other cheating on you with single replacement reactions. If you missed those videos or just need a refresher, click the playlist link in the top right corner. With all this being said, let's dive into double replacement reactions. Double replacement reactions are very similar to single replacement reactions, except instead of having one compound and a singular element on the reactant side and product side, we now have two compounds on both sides of the equation. Because of this, we can use the equation AB plus CD yields AD plus CB. To keep with our dating illustration, let's use this illustration to remember this reaction. You and your significant other are going strong, and after some allotted period of time, your attraction to each other starts to dwindle. Instead of breaking up with your significant other, you decide that you need a side relationship. Little did you know that your counterpart is also cheating on you with the significant other of the person that you are cheating with. Eventually, both of you find out about the other's transgressions and decide that it is better that y'all stay apart and stay with your new flings. This confusing love web that you have now woven has left both you and your significant other with new partners that you did not have in the original plans. So we can see that we started off with two different compounds, couple AB and CD. Then we go through a whirlwind of circumstances that eventually lead us to two new compounds being formed, couples AD and CB. When it comes to double replacement reactions, we follow the same rules as we did with single replacement. Like replaces like. This means the metal portion of one compound is going to replace the metal portion of another compound. Or you can look at it with the charges, meaning the positive portion of a compound is going to replace the positive portion of another compound. Some key things to look for when recognizing these types of reactions are there two compounds reacting together and no single element? Is there some form of the word neutralization or neutralize there? Finally, if you see the word precipitant or precipitation, that can also be an indicator of double replacement reactions. Let's try an example of this. Write the chemical equation for a reaction that would occur between silver nitrate and sodium chloride. First, we're going to write down what we know. We have silver nitrate and sodium chloride reacting together. That means that these are reactants. Next, we notice that both of our reactants in this reaction are compounds. This is a huge indicator that this is going to be a double replacement reaction. That means we need to break these compounds into their components. Starting with silver nitrate, we can break that down into a positively charged portion, silver, and a negatively charged portion, the nitrate polyatomic ion. Then we can move into our sodium chloride compound. We also break that down into its charges by saying the sodium portion is positive and the chlorine portion is negative. Now that everything is labeled, we can start switching our molecules up. It does not matter which charge you choose in the compound, just as long as you switch the same portion or same charges on both compounds. So let's take our positive portions of the compound and switch them with each other. By doing so, we get silver chloride and sodium nitrate as our products. Just to show you that this doesn't matter which charge we switch out, let me refer back to our original reactants. If I switched the negative portion of my compounds, I would get silver chloride and sodium nitrate once again. Here's another example. Write the chemical equation that would occur between lead-2 nitrate and potassium iodine. Once again, my first step is going to be write what I already know. We are given lead-2 nitrate and potassium iodide as our reactants, so we need to write those into our compounds. We notice that there are two compounds on the reactant side, so we immediately think double replacement. Because of that, we need to break these compounds into their respective charges. Lead and potassium are both positive portions, while the polyatomic ion nitrate and iodine are the negative portions. Next, we choose which portion we are going to switch out. I'm going to switch out my positive portions. So, once we switch them out, we now have potassium nitrate and lead-2 iodine. My final step is to balance our equation, and we get lead-2 nitrate plus 2 potassium iodides yields lead iodide plus 2 potassium nitrates. I hope this video helped you out, and thank you for watching it to the end. If you liked it, give it a thumbs up and don't forget to subscribe. If you are one of my students and want to continue through this unit, check out the playlist at the bottom right of the screen. If you want to see my most recent video, click the button at the top right of the screen. If you are a fellow educator and liked this video, visit my Teachers Pay Teacher store linked in the description where you can find resources to complement your teaching. In saying all this, keep up the good work and good luck in your classroom this year.